As per the earlier video, we now can set up Torquepro and we can record the fuel consumption and the PIDs on the engine for RPM and speed, etc. The next stage is to perform a drive test where we can record the fuel consumption data over a set distance and set route so that we can quantify the actual fuel consumed over that route, which we will then compare again once the BOOSTplus has been through the engine and we've done the cleanup. We can then repeat the test and we can also then record the change in the fuel consumption over the same route. So now we have our data, RPM, speed and fuel flow recorded on the Torquepro. These are the three main fields that we will focus on when we look at the change in consumption from the BOOSTplus. We are aware that as you apply the throttle, RPM will increase, speed will increase, and fuel flow will also increase. As we release the throttle, the RPM will now decrease, speed will decrease, and fuel flow will also decrease. Now if we fix the speed of the vehicle, the only variable becomes the fuel flow, and this will be dependent on the torque on the engine. As we go up a hill, the torque will increase and the engine will compensate by increasing the fuel flow to maintain the same speed. As we go down the hill, if we maintain the same speed, RPM will be fixed and the fuel flow will decrease. So if we are now doing a fixed drive test, the only variable left is the fuel flow, which we can record and then plot. So we have here a plot of the fuel flow rate of a Nissan X-Trail, which performed a drive test at a fixed speed of 100 kilometers an hour for a distance of 26 kilometers. So with the speed fixed, we can see the variation in the fuel flow as the vehicle traverses the undulations and hills in the road. As we approach the hills, the fuel flow increases due to the increased torque applied to the engine, and the ECU will compensate by increasing the fuel flow. On the flatter sections, you can see the smaller variability in the fuel flow as the engine adapts, or the fuel flow adapts to the conditions of the torque applied to the engine. Now we've completed our baseline, we can now apply the boost for a period of at least 7 days to allow engine cleanup, and then we can now repeat the same test over the same set distance and set speed. We once again record the fuel flow over the test route, and now we can compare the original baseline versus the fuel recordings using the BOOSTplus. So under this we can see the green is the fuel flow rate with the BOOSTplus, and the purple is the original baseline as we recorded earlier. So this was a vehicle, a Nissan X-Trail, which performed the 26 kilometer route at the same speed of 100 kilometers an hour, and now you can see the difference in the fuel flow rates at the same points in time over the set route. So by comparing the total fuel consumed over the same route, we can see that by the application of the BOOSTplus, this vehicle has achieved a fuel saving of 15%. So in summary, for the test to be effective in demonstrating the increased efficiency achieved by the application of BOOSTplus, the user has to define a suitable test route. We will then prepare the baseline recording using the Torquepro. We will then apply the application of BOOSTplus to the fuel supply for a minimum of 7 days to achieve cleanup in the engine, and then we will repeat the test under the same kind of driving conditions. From this we can take the recordings from both drive tests and then we can cross-analyze to see the fuel saving achieved.